Okay, this is the talk. We're going to be talking about taking the Envoy proxy beyond the typical use cases. I think a lot of people don't think that Envoy is associated strictly with Istio service mesh, but it turns out that it's a building block that can be used for a lot of other cool things. It's not working. Sorry, a little difficult here. Okay, so I'm Steve Wong. I work for VMware as a software engineer. I've been working on Kubernetes since 2015. Starting in the storage area, I've worked in the cloud provider plugin for running Kubernetes on vSphere, and I'm currently co-lead of the IoT and Edge working group on Kubernetes.
Yeah, hey everyone, I'm Steve Sloka. I work for VMware too. I help maintain Contour and Gimble at VMware.
So our agenda today, you can read this, but we're going to do an overview. We're starting with the assumption that you know what Kubernetes is, that you've heard of a service mesh like Istio, but if you haven't, we'll do a little recap, but if you're completely new to this, buckle up, because we're going to jump right into it. We're going to move on to covering opportunities to use the Envoy proxy beyond simple service mesh, using it as both an ingress, a load balancer. We're going to do some demos showing you how you can use this to bond even non-Kubernetes things, so both apps and services that are running on legacy VMs or bare metal, using them in conjunction with things hosted on Kubernetes. So just a recap. The microservices model presents a lot of challenges. You've got more interconnects of more network nodes, and these are going into more places, on-premises, public clouds, multi-cloud edge. These new models place app components much less deterministically than before, and these things are often very short-lived. It's rare to find an app developer who has great skills in networking and security. You know, when you ask people to take on their jobs, take on jobs that are beyond their skill set, mistakes will be made. So this whole concept of using network proxies or service mesh basically amounts to helping to solve this problem of requiring broad swaths of expertise to eliminate mistakes. So Envoy is an open source project. It was started by Lyft back in 2016. Its goal was to move the network details along with some security aspects completely out of the application and make the network transparent to both app developers and the users of those apps. I think the key aspects of its architecture are that it was completely API driven and it supported dynamic configuration. That meaning that you didn't have to restart, reboot it, that you could reconfigure this hot. It also offered top-notch support for observability and debugging to help you do troubleshooting. I think the best way to view Envoy is as a full-featured network filter driver. That is, it can be configured to take network traffic, perhaps manipulate it a bit and forward it on under API or programmatic control, and all this can be done hot. So why service mesh? You know, the Envoy slide called out the challenges we face and what we're trying to solve with microservice architectures and multi-cloud deployments. The best way to look at this is to look at Envoy as a building block and a service mesh as a higher level tier that configures those building blocks so that you can use them. You know, this is a lot like the Kubernetes control plane could be viewed as an orchestrator or manager of the lower building block of container runtimes and container images. So Istio is one example of a service mesh. It's perhaps the most well-known, the most well-covered in conferences like this. Its features fall into the four major categories you see here. Connecting things, securing things, controlling operations both at the app deployment level and at the network level, and finally observability, which involves monitoring things for things being healthy or going wrong and helping give you an edge on troubleshooting when things do go wrong. The Istio service mesh is commonly thought of something that would support Kubernetes workloads. But what do you do when you have something that isn't a Kubernetes workload? A lot of us have legacy components, whether they be bare metal machines or VMs. Are those things just dinosaurs that have reached the end of their life, or is there something you can do about this? It turns out that there are a couple things. One thing that I'm going to tell you exists, but not cover in detail now, is something called Istio Mesh Expansion, and that's a way to connect your legacy Linux machines, whether they be VMs or bare metal, into an Istio service mesh. I did a talk on this at Open Source Summit Japan, and it got recorded, but it was so detailed. It was one of these, I signed up for the talk, I got a 1 hour slot, and when I finally put it together, it really needed 2.5 hours. I'm not going to try to reproduce that here, but I took my slides from that and put them at the end of this, so when you download this deck, it's already uploaded to the SCED app. You can see the details on that. So come back to that later, but you can indeed use an Istio service mesh with mesh expansion to talk to these. The only thing documented at this time is doing that within Google Cloud, talking to VMs hosted within the Google Cloud. But like I say, I gave a talk on using it to connect to join bare metal and VMware VMs. I believe you could use it generically. It's just that this is not a well-documented subject. Just to summarize what's in the slides hidden in this deck, the preconditions are that you have to install Istio with mesh expansion enabled. You'll need a load balancer. If you're doing this kind of in a home lab, MetalLB will work. Otherwise, you can use a commercial load balancer. On each VM, you configure a cluster.env file, some key insert files. You install the Istio Envoy sidecar Debian package. Istio actually, or Envoy predates Kubernetes, so it actually was originally deployed as a package for Linux. I don't believe there's a pre-built distributed package, an RPM, if you're running something other than Ubuntu or Debian, but I hear that you can find them out there somewhere. You verify that Node Agent works. If you're hosting a service on a VM, you have to define a service entry. Bottom line is these steps are fairly involved. There was a speaker who made a crack at the Rejects conference on Saturday who said that Istio installs 1 million CRDs into Kubernetes. That's an exaggeration. It's actually just 23 the last time I looked, but it is a little bit complex. I'm about to turn over the stage here to Steve, who's going to show you an alternate method that still uses the Envoy proxy like Istio would, but it both does it in a simpler way, perhaps with a few less features, but perhaps with a few features that you can't currently do with Istio. So take it away, Steve.
Okay, thanks, Steve. So what we're going to do is figure out how we can enable things like a service mesh without deploying a service mesh. And we're going to use some tools today to help us demonstrate this. One thing I want to make clear is that the tools I'm using and the technologies aren't required. So I'm going to show you some things that I work on. I'd love it if you used it, but by no means you have to use those tools. Take away from this is the pattern that we're going to apply, and then insert your tool and your proxy however you want to do that. So the first thing is why not, right? Why not deploy a service mesh? Seems like everyone's doing that. Well, one, they're complex, right? There's a lot of overhead that's get added to your cluster, a lot more resources. They can make things difficult to debug, and I'm sure by the time the video comes out for this, a lot of these problems will be solved. But there's a lot going on when you deploy a mesh. So what I want to do is look at using an Ingress controller to help solve this problem. So we'll look at using a Contour. So Contour is an Ingress controller for Kubernetes. Again, it's based on Envoy. And some features of it is that it's dynamically updated. So we can update configuration and pass that down to Envoy without losing connections or reloading configuration. We can safely support Ingress in a multi-team environment, right? So you've got lots of teams working on your Kubernetes cluster. We can solve that problem through this thing called delegation of routing. So we can feel safe that teams can self-manage their Ingress resources and not have the issue today where if two teams define the same path with the same prefix, you'll get a production outage, right? We can solve that with some things in Contour. And lastly, we want to try and avoid the annotation sprawl, right? So place things in the spec where they belong, things like service weights, load balancing strategies, those sort of things. So here's how Envoy gets, or Contour is architected. So you'll see we have Envoy as the data path component. All traffic routes through Envoy. Contour is the Ingress controller. So its job is to look at the cluster and look for services, for endpoints, secrets, Ingress resources, all of those information. When it sees something change, it builds a new configuration and streams that down to Envoy. And then Envoy will route your request into your cluster. Well, let's take this kind of view and kind of build it up a little bit more. And let's look at it in this kind of view. So what I did here is I took the same idea, but I've introduced this routing cluster, right? So if we leverage Kubernetes, I get horizontal scale. So I can have all my routes, or all my traffic in this routing cluster be routing horizontally. And then what I can do now is instead of just targeting a single cluster, I can target many different clusters. Maybe it's a bunch of different Kubernetes clusters, or it's OpenStack or VMware even. And this is great because I can help move my journey to Kubernetes. So maybe I'm fully a VM infrastructure today. This gives me a path now to move some of my infrastructure to Kubernetes, but in a stepwise manner. It also allows me to route to endpoints that may never be containerized. I used to work at a large healthcare organization, and there are some applications that just will never be containerized or put into Kubernetes. So this gives you a path to move your other apps to Kubernetes and leave those apps running as VMs. Also can help you with migrations, right? You want to move from Kube 115 to 116, build a new cluster, smoke test it, and then move your traffic over again with the introduction of this routing cluster. But what about internal requests, right? Meshes are great for this. You can have your pods and your services talk between each other. So I'm going to look at a way that we can help introduce this concept as well. And we're going to add another tool called Gimble. And I think of Gimble as a service discovery component for Contour. So Gimble's job is to go out and look for endpoints and remote clusters, right? So in the case of OpenStack, it's going to go look for all the VMs that are running, and it's going to copy them into the routing cluster. And it's going to copy them and store them in that cluster as services and endpoints. So we're leveraging basic Kubernetes objects. And then once we have those objects in this routing cluster, I can now make routing decisions against that. And the last thing I want to say is that Contour is not a service mesh. So if you're looking for a service mesh, you're looking for a mutual TLS, this will not solve your problem, right? What I'm going to try and focus on here is to have you enable routing and having all your applications talk together in a very simple manner. But if you need a service mesh, then I recommend you go and deploy that and go down that road. So let's go and demo some things. So I've got a lot of hardware up here. And this is a demo, or overview of what I've got. So what we have is I've got, on my Mac, I've got 3 clusters running in Kind. Kind is Kubernetes and Docker. So if you're not familiar with that, it's a way that you can spin up a Kubernetes cluster using only Docker. So I've got 3 clusters running on there inside a Linux VM. And then on this Intel NUC here, I've got vSphere running. And I've got a few Linux Ubuntu VMs. 2 of them are running an app API, and 2 of them are running a web API. And finally, I've actually got a full Windows 2019 server running on there as well.
Yeah, and these are, the ones on the vSphere are not in Kubernetes in any way. So
absolutely.
As VMs, and they could be bare metal. And the interesting thing is that should be obvious because we've got one that's even Windows here.
Yeah. And finally, I have a Raspberry Pi. So this is a Raspberry Pi 4 I ordered last week from Amazon. Cool. And the last thing that we're going to need for this talk is a lot of luck. So hopefully this will all work very well. So let me go ahead and, where's my display? Okay. So here is my Linux VM. All right, so let's go ahead and start by looking at this vSphere API, right? So these are all, again, the VMs that we just saw on that last screen. I have my 2 API VMs here and my 2 web server VMs. And what you'll notice is they've all got IP addresses. So my web servers are running on, again, an Ubuntu VM, and I have .12 and I have .11, right? Those are the 2 IP addresses for my web server. And down here, what you'll see is I've got some attributes, right? So these attributes are a way that we can define metadata to our VMs running in vSphere. And I've added this thing called an application, a port, and a project. So what Gimble does is Gimble is a controller that runs in Kubernetes. And again, it goes out and it finds these endpoints and copies them into that routing cluster. So what I do is I've got a mapping now. So the project maps to a namespace in that routing cluster. So this is my example. We're going to have a marketing team. So the marketing team is going to have this VM, and it's going to be part of the web application. And the application maps to a service in Kubernetes, right? Now that I have a namespace and a service, I can add endpoints. And my endpoints come from the IP address assigned by vSphere, as well as the port here we've defined. So now that I have two web VMs, you'll see the Web 01 matches the same thing as Web 02, right? It has the same attributes. So essentially what I'm going to end up in my routing cluster is a service with two endpoints living in one namespace, right?
Maybe let's make a point that for people not used to vSphere, these attributes are akin to labels in Kubernetes. So they're an optional feature that you can use to associate metadata with VMs.
Great, so let's go ahead and take a look at, if I go ahead and get my services and endpoints in the marketing namespace, what you'll see here is, again, I've got that mapping now. So here's that web service that we applied with that annotation. And you see I've appended VMware to it. So we need to give it a backend name, right? I could have multiple clusters. I need to give them an identity. So I've given the identity, just called it VMware, right, for this demo. If I had another cluster running, I could call it, foobar, and it would get foobar-web. And then here you can see the endpoints that came through, right? Again, that .11 and .12. So now you can see from this routing cluster in Kubernetes, I've got all of those endpoints living in VMware. So now what we can do is let's go ahead and wire some things up. So what I want to do is I want to have traffic now hit my marketing website. So my marketing team is running under this company called pixelproxy.net, and this is their domain. So what I'm going to first do is create this root namespace. So in Contour, we have this idea of we have a custom CRD, and it's called HTTP proxy. And it's how we're going to solve this multi-team, multi-cluster type networking. So this Ingress object helps us, again, define all those features we described. You couldn't do these things with Ingress today, just in the current version. So what we'll do is we'll have a root proxy, this pixelproxy.net, and we'll tuck it away in a root namespace. And what this does is this lets us store our certificates and secrets away from all of our users, right? Because what we can do is we can delegate permissions across namespaces. So now I can have my teams, again, self-manage their resources and not have to see or view secrets tied to these Ingress resources. So here this is giving us permissions to the marketing team, and we're going to give it to this proxy called default proxy. Down here, we'll actually define the actual proxy, right? And this is that definition in the marketing namespace. And what you see is that basically / for pixelproxy.net is going to route to the VMware web service. And again, if we go back to our services and endpoints, that VMware web service is pointing to those two Windows or two Linux VMs running my website. So let's go ahead and apply this. Great, so now those are applied. And if I come here and I go get my proxies, you'll see I've got two of them, right? Here's the root one, and then here's the one that's delegated to. So if we come over to our browser and we go to pixelproxy.net, what you'll see is I get the requests, right? So this is hitting Web 02, and the response on this isn't very exciting, but it helps you understand where requests are going. So the VM is responding with Web 02 or Web 01. So if we go ahead here and do a curl, we'll just curl it for every half second. And you'll see it better. So you'll see Web 01 and Web 02 responding kind of half and half, right? It's getting half and half traffic. So now we basically wired up our VMs to get production traffic through this routing cluster. So next what I want to do is go ahead and deploy a blog. And in our case, the blog is running under a Windows server. So down here back in vSphere, I've got this Windows box. And again, it's running Windows Server 2019. So here's that home screen. So what we'll do is we'll go wire it up, but then we're going to give them a path for that. So this is where we'll define that in Contour. So we'll say that the pixelproxy.net domain gets the path /blog. And for that path, we're going to route to the VMware Windows service. And again, that maps to the service that Gimble went and discovered for us. So if we go ahead and apply this one, what I should have now is the root should still work, because we didn't change that. But if we now go to /blog, what I'll get is Windows, right? So there's my Windows server now routing. Whoops. There we go. So now you can see that I've got requests hitting this routing cluster and now going to all of my VMware infrastructure, or my virtualized infrastructure. So now let's go ahead and move that infrastructure. Let's containerize our front-end web application. So this one here. So we'll move this one now from our virtualized VMs to containers. So what we'll do is we'll first go ahead and we'll deploy a service, right? And I'm cheating and I have a make file, so I can say deploy blue. And what this is going to do is it's going to go deploy that front-end web application into my blue cluster, right? So again, I have 3 clusters. I have my routing cluster and then my 2 children clusters. So now my blue cluster has that application deployed. So if we go ahead and get our services and endpoints again, we'll see now we have this blue service that came through. Again, I've labeled that backend blue cluster as blue, and it's called web. So now I have this blue web, and I have these 3 endpoints, because I have 3 replicas of 3. So now what I can do is we can go wire that up. So what we'll do is we'll do a Canary deployment. So this is what this will look like. So in HTTP proxy, we can define multiple upstreams. So we can have our current service, which is the VMware web. Again, that's living on the VM infrastructure. And now we'll route to the blue service, which is in the Kubernetes infrastructure. And we'll add a weight to this. So we'll add a weight of 90 to the VM and a weight of 10 to the Kubernetes one. So after we get this, we can see how this gets routed around. Cool. So let's just do it with the while loop here. So now what we should get mostly the Web 01 and Web 02, and every now and again we'll get the blue cluster replying. And there's a blue cluster flowing through if you can catch that, because we have most of the weight hitting the VM infrastructure. So let's go ahead and we'll flip-flop those weights. So we'll give 10 to the VM and 90 to the Kubernetes one. And this is now going to reverse or add more infrastructure routing to our Kubernetes infrastructure. Right? So we can watch our logs, watch our metrics, see how it's handling. Once we're happy with it, see the blue cluster is getting most of the traffic, and then the web one's getting a little bit. Once we're happy with that, we can come through and just take away all traffic to the VMware one. And now we've successfully moved our infrastructure to Kubernetes. All right, so the next thing we want to do is move our API, right? So this application, when we access it, it's not hitting an API at the bottom, but we can have it do that. So what I'm going to do is go ahead and create an internal proxy. So up until now, we've solved the basic Ingress resource solution. We have this public request hitting the front-end application, the first step. Well, now I'm going to go deal with the second step, and this is where meshes kind of can shine and do cool things. But what I have now is I can add a .contour domain inside my cluster. And what I can do is create routes now, like I did with my Ingress resource, but now for internal requests. So what this is going to do is it's going to create another Ingress resource, and this URL is going to hit this VMware API. Again, this is the API running in my VM infrastructure. So we're going to have our containerized Kubernetes one we just moved access this VM infrastructure living over in VMware. So let's go ahead and apply this one. This is 4A. All right, cool. And then let's go look at our proxies again. You'll see now I have this extra one, this api.marketing.contour. So what I have to do next is I have to go tell my blue service to go use that. So here I can pass it in through an environment variable. So this environment variable tells that application, hey, this is where your API lives. So let's go ahead and switch context to my blue cluster. You can see that down here with the blue. And I will apply the 4B. Right, so now if I do a watch on our pods, you can see those are rolling out. We did a rollout, I didn't get it fast enough. But you see they're 10 seconds old. So now what should happen is when I make a request to this application, the Kubernetes infrastructure running in the blue cluster is going to make a call to the APIs running in VMware. And there it is. So you can see down here the API 02, right? You can see it hitting API 01, API 02, and that's the spot down here. So the second half is the web server making a request to the API. So now let's go ahead and move that infrastructure over like we did for the web app. So we'll go ahead and deploy the same API as containers running in Kubernetes. So while I'm still in the blue cluster, we can apply this 05, and we'll get our pods. You see those are spinning up now. Those are my API pods spinning up. All right, let's go back to here and let's go and go look at our endpoints. And we'll see now we have a blue endpoint from Gimble. So Gimble went and discovered that endpoint and added that API server into there. So now that we have that, we can go and update our application. So we'll just change our our internal proxy, instead of porting to the VMware infrastructure, we can have it just point to the blue cluster, right? So now we won't do a Canary deploy, we'll just do a blue-green deploy. We'll just pull the switch and instantly flip it over. So now this is again, this is the internal API. So let's go ahead and apply this one. This is 4A. All right, so now, wait, that's it unchanged. No, I'm in the wrong cluster, that's why. Okay, so now if we go ahead and do that curl, let's do it from here. We'll see if I get the blue API. So now it's hitting the containerized infrastructure. So now I've successfully moved my web application from my VMs and my API from my VMs. Now last thing we're gonna do, just for fun, we will go ahead and talk to bare metal. And again, that's my Raspberry Pi sitting there. Now I don't have a discoverer in Gimble to do this because there's not really a good API for bare metal. We could probably figure something out. But for today, we'll just create basically another service and an endpoint. So this is gonna create a generic service for me called bare metal. And we have one endpoint here, which points to the IP of that Raspberry Pi. So if I go ahead and apply those 6, if we look at our services again, we'll see now I have this bare metal service, and it has an IP address of .50. So let's go ahead and edit, not that, let's go ahead and edit our proxy, the default one, and we'll come down here and we will change out from blue web, we'll hit bare metal. Right, so now if I hit our requests, we should get bare metal returning, and we do, right? So now it's actually hitting requests to the Raspberry Pi. So hopefully you can see now where we can kind of like add some cool networking, add some cool bridging of applications. Again, this isn't gonna solve your service mesh problem, but you can see how now we can have interoperability between all these different endpoints living across my cluster, and hopefully this helps you work to a better spot. So I think Steve now is gonna help us move on from the end.
Okay, so where do you go to learn more? We've been talking about Contour, Gimble. They're both open source projects. The Contour project has regular working group meetings. It's on the 3rd Tuesday of each month. It turns out that would turn out to be today. So because we've got KubeCon going on, we're not going to have the one today, right, but catch up on the next cycle. So, pardon me?
Lunch community meeting at 12:30.
Yeah, we're going to get to that. So go to this site, projectcontour.io, to learn more. If you want to see if you've missed all the meetings before, they got recorded. The notes and agendas are recorded, and the portal is at that site. I don't know if we have very much time for questions, but it's fortuitous that we have an event occurring during lunch called Contour Meet the Maintainers. The map is up there, so this says in Hall C. Lunch is in 3 different places, but we're specifically going to be in Hall C, and there will be Contour signs on sticks to direct you to the area where the Contour maintainers are open to discussions and questions. So please come by. Yeah. Like I said, there's far more material in this deck that was hidden during presentation, but yeah, we simply didn't have time for it. But this deck is already on the SCED site, so go ahead and download it, and you can learn a little bit more from there. I think we do have a few minutes for questions. 5? Okay. So if anybody's got any, raise your hand, and I think somebody will bring you a microphone. Okay, well, I don't see any questions, but oh, there's one. But yeah, just to summarize what you saw, I think it's a pretty cool method to link up non-Kubernetes workloads. And there are some things like bringing in that legacy Windows is something that I don't think is even doable in an Istio service mesh.
Oh, now it's working. Hi, another question about a comment. You said that Envoy is only available for as Debian packages. There's actually Tetrade is sponsoring a site called getenvoy.io, which has packages for all the major Linux distributions, including RPMs on CentOS and Red Hat Enterprise.
Okay, thank you. So He just said you can get the RPMs and somebody is building them. Thank you.
For a typical deployment, say the entire service mesh versus contour approach, how much of complexity and processing differential you can achieve?
So
I think he asked the difference between using the approach you just showed here, Steve, and using an Istio service mesh, the difference in complexity.
yeah, so they're going to be night and day. So Istio has a sidecar injected everywhere. There's lots of other components that have to run to make Istio work. Contour is literally like one controller, which is Contour, and then a set of envoys to handle your load and traffic. So they're going to be, Contour is going to give you a much smaller footprint and a much simpler design to implement what I just kind of showed you. But again, we can't compete with some of the things that Istio can give you, like the mutual TLS and those sort of things. So it comes down to what do you need out of your network requests. If you need the things that a mesh gives you, then you might have to bite the bullet and deploy those meshes. But if you don't need that, you just want the routing, then I think this would be a great alternative to investigating.
Are there any white papers or anything that would help me to understand what the latencies might be from, say, using the Istio service mesh compared to what you have now for, different setups?
I don't know that we have anything that we could reference. That'd be interesting, yeah. I know we built a lot of this. We took latency very seriously, so we don't add any more than 20 milliseconds of latency to your upstream. But I don't have any comparisons or any kind of metrics. A lot of it comes down to your network and your infrastructure, so it's difficult to manage some of those numbers.
20 milliseconds, is that on bare metal or on VMs on like AWS?
I think we did those tests on bare metal. We validated those.
Does it support the mutual TLS when you deploy the Envoy in VM?
No, we do not implement or implement mutual TLS, right? So all those requests that I did are not automatically encrypted by certificates.
Okay.
So that's again where Istio would help you if you needed that feature.
Gotcha.
Or another mesh.
Gotcha. Yeah. And is there a concept is like a one management plane and multiple control plane? That's kind of like how it works. Like if I want to have a single pane window, like where the traffic goes, does the Contour supports it, or is there a?
So how is Contour architected? Is that your question? Like, is there one control plane?
So I believe like it is multiple control planes, but if I want to see the traffic goes back and forth between VM, the Kubernetes or any other bare metal, how you do that? Like in
Right, yeah, so Envoy has a whole suite of metrics that you can get, and we have example dashboards in Prometheus, so we could demo that, but we have, if you deploy all the metrics in Envoy, because everything's routing through that routing cluster, I'd see metrics on every single hop that went around. So for the requests from the front end to your application, and then from your application to the back end, if it went through that Envoy, then then I can give you all the metrics you'd want on seeing that, yes. Anybody else?
All right, thanks a lot.
Okay, thanks for coming. If you've got more or just want to chat, come to that Meet the Maintainers event. Thank you.